This is the 2019 free response 4 through 6. And so let's read the prompt and let's talk about what we're doing here. So number 4, a cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. Our figure is over here to the right, and so we can see the cylindrical barrel, and we have water in the barrel, and we have a diameter of 2 feet. The water drains out through a valve that is not shown at the bottom of the barrel. So water is draining out. The rate of change of height, remember from our related rate days, the rate of change of height would be dH dt. In the water in the barrel with respect to time, and there it is, dH dt is given to be negative 1/10 square root of h, where h is measured in feet and t is measured in seconds. The volume of the cylinder is given by pi r square h. So we have our given information in the problem. And so letter A, find the rate of change of volume. So let's translate that. Remember, we're looking for a volume rate, so we want dV dt when the height is 4 feet. So basically what's happening is our goal is to find dV dt, we don't know, when h is equal to 4 feet. So they gave us the formula for volume to be volume's pi r square h. And in this case, since it's a cylinder, we know that the radius, if the diameter is 2 feet, we know that the radius is 1 foot all the time. That's never changing. So our updated formula then would be V is equal to pi. If r is 1, 1 squared is 1, so it's pi h. So that makes us the dream of a related rate problem. So we're going to take the derivative of both sides. The derivative of V is dV dt. The derivative of pi h is pi dH dt. So when we substitute, we know what dH, remember we know that dH dt is equal to, let's write that over here, negative 1/10 times the square root of h. So we can find that when h is equal to 4. So if I substitute 4 in here, that will give me, don't put an equal marks there, that'll give me negative 1/10 square root of 4. The square root of 4 is 2. So that's negative 2 tenths, which is equal to negative 1/5. So if we substitute that back in place of dH dt, then dV dt is equal to negative 1/5 pi, or that's the same thing as negative pi over 5. And since that's volume, that would be cubic, let's see, was it measured in feet? Cubic feet per second. And so we look at our scoring guide and we can see same thing that I just showed you, and the answer is negative pi over 5 cubic feet per second. 1 point for doing the implicit differentiation to get take the derivative of both sides, and 1 point for the answer with the units. So if you did not include your units, you're not getting that answer point. Definitely don't want to lose points for something like that. All right, letter B says, let's change colors here. Letter B says, when the height of the water is 3, so h is equal to 3, is the rate of change of height rate is dH dt, is that rate of change of height increasing or decreasing? So we want to know if dH dt is increasing or decreasing. So we're going to need the derivative of dH dt, which would be d squared h over dt squared. So that basically that just means we're going to find the derivative of our model. So when we find the derivative, I'll do it here, and then we can look at the scoring rubric. So we know that dH dt is equal to negative 1/10, and I'm going to change that to h to the 1/2 power. And so when we take the derivative, we will get d squared h dt squared. And now we're going to need the power rule. So 1/2 times negative 1/10 is negative 1/20. H, decrease the power by 1, and then don't forget the dH dt. That's going to be the common mistake, is to forget that dH dt. So then that's going to lead me to, I can take that h to the negative 1 down to the denominator to make it negative 1/20 square root of h, because I'm going to be substituting a number in just a second, multiplied by dH dt, which was negative 1/10 square root of h. And we wanted to know that at 3. So I'm going to substitute 3. That'll give me negative 1/20 square root of 3 times negative 1/10 square root of 3. So I can see that a negative multiplied by a negative is a positive, so that's going to be greater than 0. So what was the question? The rate of change dH dt is going to be increasing. So we can see that oh yeah, because the square root of 3 is divided out. All we had to show was that we're going to get a positive value. So let's look at our scoring rubric right here. They did the same work that I did. Bring that down so you can see. So we find the second derivative. Here's our implicit differentiation. There's the substitution of dH dt. Now they got 1/200, and I could get the same thing if you look at my work over here. If I divide the square root of 3 out with the square root of 3, I will also get 1/200th, but I really only have to show that the derivative that I just found is positive, or in this case, the second derivative. The points are awarded for, sorry about this, just trying to make sure everything's in the window. So there's 1 point for doing the implicit differentiation, 1 point for the answer with explanation that the derivative is positive. This is fine. This is just finding the derivative, the first part of the derivative right here without the chain rule. So you do get a point for finding that derivative, even if you forget the chain rule. You can get 1 point for that, but then you get 1 point for the chain rule, and you will not get your answer point if you don't get the chain rule, because you're not going to be able to get that right. In letter C, they are, let me change colors again. In letter C, they are telling us to go back now. At time 0, the height of the water is 5 feet. So there's an initial condition, 0, 5. And they want us to use separation of variables. In other words, they want us to solve the differential equation. So we're going to take our differential equation, dH dt, and dH dt is equal to negative 1/10 square root h. So I'm going to divide both sides by the square root of h. I'll get dh over the square root of h is equal to negative 1/10 dt. So I'm going to get 1 point for that separation. I would do a rewrite here to make this h to the negative 1/2 power dh equal to negative 1/10 dt. I'm going to integrate on both sides. I'm going to increase the power by 1, so that'll make 1/2 divided by 1/2 is 2. On the right side, I'm going to get negative 1/10 t. Don't forget c. I'm going to divide both sides, or maybe I'll go ahead and solve for c. I had an initial condition of 0, 5. So 0 is the time and 5 is the height, so I have 2 square root 5, because remember h to the 1/2 is square root, equal to negative 1/10 of 0 plus c. So c is equal to 2 square root 5. I'm going to substitute that back where I left off, which is here. So I have 2, I'm going to write it as square root of h equal to negative 1/10 t plus 2 square root 5. We're trying to get h by itself, so I'm going to divide everything by 2. Now you can make this ugly or you can simplify it. Square root of h is equal to negative 1/20 t plus 2 square root 5. Now, where did that come from? That's negative 1/10 divided by 2 over 1. So I'll multiply by the reciprocal to get that 1/20, and then plus 2 square root of 5 over 2. That's how I did that simplification. And then lastly, to get h by itself, I'm going to square both sides. Negative 1/20 t plus 2 square root 5 quantity squared. All right, so let's go to the scoring rubric and see how that's scored. Okay, so you get 1 point for correctly separating your variables, 1 point for getting both antiderivatives on both sides correct. You get 1 point for your constant of integration and using your initial condition of 0,5, and you get 1 point for getting h by itself. If you do not show your separation of variables, you will get no points whatsoever. If there is no C, the most you can get is 2 out of 4. You can get the point for the separation and you could get the point for the antiderivatives, but you cannot get any more points. So that's problem number 4. Problem 5. This is our area volume problem. So in problem number 5, we have R is a region enclosed by the graphs of g of x and h of x shown in the graph above, and the vertical line x equal to 2. So we're going to, first of all, we have to figure out which graph is which. Let's see. And the vertical, there's the vertical line x equal to 2. The parabola is going to have a vertex of positive 1 and up 6. So this graph is h of x, and this graph down here is g of x. So that's going to be really important that we understand that. The vertical line x equal to 2. So we're finding the area of the region. So remember area, there's a top and a bottom, so we're going to do top minus bottom. So that is going to be, in this case, h of x, which is on top, minus r of x, which is on bottom. And it says actually find the area. This is not a calculator problem, but there are ways to not have to worry so much about the trigonometry. So we're going to accumulate the area starting at 0 to 2. Top curve, 6 minus 2 times the square root of x minus square, minus bottom, negative 2 plus 3 cosine pi over 2x. You get 1 point for your integrand. So just by writing that up, you've already gotten some things done. Now there's 1 point for the antiderivative, of the cosine, because we're going to need a u substitution here to do that integration, but let's worry about that in a second. The antiderivative of 6 is 6x. The antiderivative, since the inside function is x minus 1, the derivative is x, so you can do a u substitution here, but we're going to increase the power by 1 and divide by the power. So that's the antiderivative of that function. The antiderivative of negative 2 is negative 2x. And then here, let's bring this over to the side. We're going to need a u substitution, so u is equal to pi over 2x, and du is equal to pi over 2 dx. Multiply both sides by 2 over pi. Okay, so then when we do our substitution, I'll do it down here, we'll have 2 over pi antiderivative of, and we're just doing this part right here. There was a 3 already out there, so 3 times that. cosine of u du. The antiderivative of cosine is sine. Check it. The derivative of sine is cosine, so we know that. We can put the pi over 2x back in. There's the 6 over pi, and we can keep our bounds in terms of 0 to 2, or you can do the antiderivative here and get 6 over pi sine of u, and you can integrate that. You can change your bounds. I'd have to come back over here and substitute 2. Remember, we substitute in here. So 2 times pi over 2 would be pi. So the upper bound would be pi, and 0 would be 0. So you can do the same thing and get the same numbers. When you're trying to find the sine of pi and sine of 0, you actually can leave them as sine of pi and sine of 0 if you want to. You can leave your substitution as, I'll say ugly, it's not really ugly. You can leave it just like that and get the full answer credit. So the other points are 1 point for the antiderivatives of all the other terms and 1 point for the answer. And the total, if you calculate it all the way out, the area is 44 over 3. But again, leave those answers in a, quote, ugly format. They don't have to be simplified. For part B, the area of the region is the base of, region R is the base of a solid. For the solid at each x, the cross sections are perpendicular to the x-axis, so that tells us we are in terms of x. And the area formula, notice they're already giving me the area formula. It's not like a square or a triangle or a semicircle where I create the area formula. It's already given. So the formula, the area formula is ready to go. I don't have to do anything to get it ready. Find the volume. So remember, when we're doing by cross sections, we accumulate that area formula from the low bound, in this case, of 0 to the high bound of 2. So all we have to do here is accumulate from 0 to 2 area formula, which is 1 over x plus 3. If we do that as a u sub, u is equal to x plus 3. du is equal to dx, so we don't really have to compensate for anything. So that's the antiderivative of 1 over u, which at du, which is ln absolute value of u. So that's where the ln of absolute value of x plus 3 comes from. And then you can simplify that by substituting the upper bound minus the lower bound. Don't have to clean up, don't have to use log properties. You can leave it just like that. 1 point for the integral, 1 point for the answer. And lastly, we're going to write but do not integrate an integral that gives the volume generated when R is revolved or rotated around y equal to 6. So we're going to come back up here to the graph, and we're going to put in 1, 2, 3, 4, 5, 6. We're going to put in the line y equal to 6. So I know now that I am in terms of x, and there's going to be a hole in the graph because there's some space between the axis of revolution and the curve. So I'm going to have big R of x, which is top minus bottom, from the axis of revolution to the outside curve. So in this case, that'll be 6 minus g of x. Little r is from the axis of revolution to the inside curve. So that's 6 minus h of x. And remember, all we had to do was set this thing up. We did not have to evaluate. Because we're revolving, we're going to have a pi, low bound of 0, upper bound of 2, big R squared minus little r squared. Check your parentheses. 1 point for the limits and the constant, that's including the pi. 1 for the form of the integrand. I can't tell you, I did not grade this problem, so I can't tell you exactly what that means. I feel confident that it likely means that the order of these is important, not g minus 6, but 6 minus g, top minus bottom. and then 1 point for the integrand itself. Problem 5. And finally, problem number 6. I apologize, I did not print the scoring guide on this thing, so we're just going to do the problem. I'm going to do the problem for you from scratch, and you can check the scoring guide as posted in our solutions online. Okay, give me a second here to get started. So we have some symbolic derivatives going on, and I'll try to keep this in the window and stay focused here. We have a function f, g, and h. They're all twice differentiable, so they have a first and second derivative, and they're giving me some y value. G of 2 and h of 2 have a y value of 4. The line y equal to 4 plus 2/3 x minus 2 is tangent to both the graph of g and h at x equal to 2. Letter A, find h prime of 2. Well, since we have the line tangent to h, so y is tangent to h. That tells me this is not what we're writing down as the answer, but I'm just telling you how to do it. The slope of the tangent line is derivative. So if we look at our line, the slope of that line is 2/3. Therefore, h prime of 2 is 2/3. That's easy. B. Let a be the function given by a of x equal to 3x cubed h of x. I want a prime of x, and I want a prime of 2. So this is a product, so I'm going to need the product rule. So a prime of x is the first times the derivative of the second. There's no chain rule needed here, plus the second, h of x, times the derivative of the first, which is 9x squared. So a prime of 2, substituting 2 for x, 2 cubed is 8, times 3 is 24. We already know from part A that h prime of 2 is 2/3, plus h of 2 is given in the prompt to be 4. And substituting 2 squared is 4, times 9 is 36. That answer is perfectly fine. You do not need to clean it up. You do not need to do anything to it. All right, going on to letter C. Sorry, I keep bumping the thing. Letter C, we have a new function, h of x. Let's see, can you see the prompt? I don't think you can see that yet. Let me do something here. Okay. We have a new function, h of x, not defined for x equal to 2. It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Show the analysis that leads to your work. Okay, so let's see what we're going to do with L'Hopital here. So we know that the limit as x approaches 2 of the numerator, x squared minus 4 is equal to 0. We know that because 2 squared minus 4 is 4, we know that the limit as x approaches 2 of the denominator of 1 minus f of x, parentheses, cubed is equal to 0. So that means that 1 minus f of 2 cubed is equal to 0. Therefore, f of 2 cubed is equal to negative 1. So I'm just following the algebra here. And I can divide both sides by -1. So f of 2 cubed is equal to 1. Take the cube root of both sides. So f of 2 is equal to 1. And that's one of the things that they wanted me to find, so I have that.